Assalamualaikum and hi guys, this is 7.1 part 4. Here are the learning outcomes. At the end of this lesson, students should be able to H. Explain qualitatively salt hydrolysis using hydrolysis equations and classify the salts formed from the reaction between strong acid and strong base, strong acid and weak acid and strong base. So we are going to do salt hydrolysis based on these three types of neutralization reaction. So are you ready? Keep your heads up and let's start. So, how do we form a salt? Salt is formed from the neutralization reaction between an acid and a base. Consider a general equation of a neutralization reaction here. So let's say we have an acid HX. Aqueous react with MOH. Aqueous forms salt MX. Aqueous as water. Right? So since this salt is formed from a neutralization reaction, must it necessarily be neutral? No, that's the misconception that we are going to correct in this lecture. Even though this salt is formed from the neutralization reaction, it does not necessarily be neutral. It can be acidic, basic, or neutral depending on the nature of the acid and base that makes it up. The properties of the salt can be determined or can be identified by using the salt hydrolysis. Salt hydrolysis. So we can see the word hydro here. That means the salt will react with water. But before reacting with water, it will first dissociate into its anion and cation. So we must know on how to write the correct dissociation equation for a salt. So let's try to write the dissociation equation for MX salt. So MX salt aqueous dissociate completely. So we are using the single-headed arrow into its cation and anion. So we know that this salt is made up from an acid and a base. So bear in mind this cation of a salt always come from a base. Anion of a salt always come from an acid. Right, so let's recap. For example, we have HX acid dissociate completely forming H plus because it is an acid, so it's going to donate its proton and also leaving X minus. Since this is an acid, this is its conjugate base and it is an ion. An ion come from an acid. So we can see here, as I said earlier, the anion of a salt always come from the acid. Meanwhile, the cation of a salt always come from a base. Let's say we have MOH base, right? This base is going to lose it to form M plus aqueous plus OH minus aqueous. So we can see here that the cation form, since this is a base, this is the conjugate acid. So the cation formed from the dissociation of a base is the conjugate acid of the base. So the cation of a salt always come from a base. Please remember that, right? Because we are going to use this later on when we are going to do the salt hydrolysis process. So how do we define salt hydrolysis? Salt hydrolysis is the reaction of an anion or cation of a salt with water. Right? So that's how we define the salt hydrolysis. Or that means we need to choose either one. So for a given salt, you need to identify whether the cation or the anion of the salt is going to react with water. It cannot be both, right? So how do we decide? Therefore, right, you must know, first thing first, you must write down the neutralization equation first. Don't worry, we are going to start from we are going to do some example later on. But for now, okay, please look on how to write down the correct equation for each reaction. So now, if we want to do the hydrolysis equation, let's say for a given salt, the cation will undergo hydrolysis with water. So cation react with water, dissociate partially. So we are going double-headed. We are using the double-headed arrow, right, forming MOH and H+. So we can see that the product is H+. So the concentration of H+ ion increases. So what happened to the pH? What do you think? Right, the pH will drop. Yeah, so it will become less than 7. Therefore, when the cation of a salt undergo hydrolysis forming H+, the pH will be less than 7, and therefore the salt is an acidic salt. Let's say, for example, for another salt, the anion of the salt hydrolyze the water molecule, dissociate partially, right, forming OH minus ions. So the pH is going to be more than 7, and the salt is going to be basic. So how about neutral? Can you guess? Let's keep your answer for now. Okay, we're going to see whether your answer is correct or not later on. So here is a simple tip for me. So if you are going to solve the problem regarding the salt hydrolysis, please, okay, you need to know on how to write these three types of equation. N stand for neutralization equation, D dissociation equation of a salt, H is hydrolysis equations. So you can remember it as Nadia equation or just NDH. Just these three equations. Like simple. Next, let's see an example. So, let's do the salt hydrolysis from the neutralization reaction between a weak acid and a strong base. So, for example, we have CH3COONA solution. That means this is the salt that we need to do the salt hydrolysis. You need to identify or classify the salt, whether acidic, basic or neutral. First thing first, you must write down the neutralization equation. Remember, NDH. So please follow step by step. So the first one, N, neutralization equation. So we know neutralization occur between an acid and a base. So now, as I said earlier, you can break up the salt into its cation and anion. So we can see that this is the anion. The anion always come from an acid. And this is the base. Okay, cation always come from a base. So we just write down, okay, base means require OH. So Na plus OH minus forming NaOH. Meanwhile, the acid, this come from acid. This is the conjugate base of an acid. So the acid is actually CH3COOH. And then neutralization equation is non-irreversible reaction, so single-headed arrow forming its salt and water. So now, after writing the correct neutralization equation, you need to identify the strength of the acid and base. How? You need to memorize, okay, because we already learned earlier, okay, strong base, okay, usually made up of MOH, right? Metal group 1 or metal group 2. So this is a strong base. Meanwhile, this is an organic acid, so it is a weak acid. Next, we do the dissociation equation of a salt. So we have our salt here, CH3COONA, dissociate completely. So please use the single-headed arrow into its cation and anion. So this Na plus come from NaOH. Since NaOH is a strong base, therefore Na plus is the weak conjugate acid. Ca stand for conjugate acid. The properties is vice versa, right? Because we already encountered this in the tutorial session, right? Since CH3COO minus come from a weak acid, CH3COH, therefore it is a strong conjugate base. So now, last equation that you need to write down is the hydrolysis equation. So remember, salt hydrolysis means the reaction of the anion or cation of a salt. So now that means you need to choose between this cation and anion of this salt, which is going to hydrolyze the water molecule. What do you think? Yes, of course, the strong one. So that means in this case, right, CH3COO minus ion, which is the anion, ionized in water because of the strength. It is a strong conjugate base. So now you need to write down the correct hydrolysis equation. So since this is the strong conjugate base, this is conjugate base. So that means in this reaction, water react as an acid. So what's the function of a base? Base is going to accept proton, right? So remember, hydrolysis equation is reversible reaction. So please use the double-headed arrow. So since this is a base, so it gains proton. Meanwhile, this is acid, so it loses proton, forming OH minus. So in order to classify the salt into its property, you must look at the product of the hydrolysis. So we produce OH minus. So since OH minus is formed, pH is more than 7, therefore CH3COONA is a basic salt. Simple? Simple. Okay, so now let's move on to another example. For example now, this is the salt formed from a strong acid and a deneutralization between a strong acid and a weak base. We have NH4Cl solution. So first, you need to write down, okay, remember Nadia equation. So you must write down the neutralization equation first. So in order to write the neutralization equation, please break up this salt into its cation and anion. The cation always come from a base and anion always come from an acid. Okay, so we have here NH3 aqueous plus HCl aqueous forming NH4Cl. Ammonia is a weak base, meanwhile HCl is a strong acid. Right? So next, second step, write down the dissociation equation. So NH4Cl aqueous dissociate completely into its cation and anion. So our cation is NH4 plus aqueous come from weak base. Therefore, NH4 plus aqueous is a strong conjugate acid. Meanwhile, since Cl minus come from a strong acid, so it is a weak conjugate base. So now last step, you must write down the correct hydrolysis equation. So can you choose by now whether the anion, the cation or anion is going to hydrolyze the water molecule? Yes, of course, the strong one. So for this salt, we are going to choose NH4 plus. So NH4 plus will ionize in water. So now you need to write down the correct hydrolysis equation. Since NH4 plus is a conjugate acid, so it's going to lose its proton forming NH3. Meanwhile, in this case, water react as a base. So it's going to accept the proton, forming H2O+. So when the product of the hydrolysis equation is, the product of the hydrolysis reaction is H2O+, therefore pH is less than 7, so NH4Cl is an acidic salt. Simple, right? Then the last one, we are going to look at the salt formed from the neutralization reaction between a strong acid and a strong base. For example, we have NaCl solution. So first, remember you must write down the correct neutralization equation. So since NaCl come from NaOH and HCl. NaOH is a strong base and HCl is a strong acid. Next, second step, write down the correct dissociation equation. NaCl aqueous dissociate completely into Na plus aqueous and Cl minus aqueous. Since Na plus, the cation, come from the base, so this is a strong base, therefore Na plus is a weak conjugate acid. Meanwhile, Cl minus come from a strong acid, so this is the weak conjugate base. So now, since both are weak, so which one is going to hydrolyze the water molecule? What do you think? Yes, neither Na plus nor Cl minus. Both cannot ionize the water molecule. Okay, so water will undergo auto ionization. Remember, we learned earlier. So you must write down for the hydrolysis equation here. You must replace it with the auto-ionization equation of water. So water self-ionize into its cation, which is H plus, and also OH minus. Also using the double-headed arrow because this is a reversible reaction. So now, how do we determine the pH? How do we classify the salt? So now you must write down the equation of ionic constant of water. Since at 25 degree in pure water, concentration of H2O plus is equal to the concentration of OH minus. So these two has the same concentration, which is 1.0 times 10 to the power of negative 7 molar. Therefore, pH is equal to 7. It is a neutral salt. So from a salt that is formed from the neutralization between a strong acid and a strong base, the salt is neutral. Are you okay? Right. So now, this is a reminder. Dissolution and dissociation of salts in water can be written in two ways. Whether look at the state of the salt. If the salt come in solid form, then you need to add water. Okay, dissociate into its ion. Okay, like this. And then if the salt already in aqueous, so just write down NaCl aqueous dissociate into its anion and cation. Please look at the state of the salt given. Right? If it is in salt, it cannot dissociate. If it is in solid state, it cannot dissociate into its ion. You must dissolve it in water first. Practice makes perfect. So it's time for us to do some question. Okay, to master this salt hydrolysis concept. So write the hydrolysis salt equation for these three types of salts. So now let's start with A. So before doing anything else, please remember to write down these three equations. I'm going to start with N, which is the neutralization equation. So for example, we have NHI equals salt. It is made up from the weak base, which is ammonia, and also HI, which is the strong acid, right? So next, second one is D, which is the dissociation equation. So NH4I equals salt dissociate completely into its cation and also anion. So this cation comes from a weak base, therefore it is a strong conjugate acid. Meanwhile, this anion I minus come from a strong acid, therefore it is a weak conjugate base. Right? So by now, can you guess whether the anion or the cation that is going to ionize the water molecule? Yes, of course, the strong. Therefore, NH4 plus will ionize in water. And the last step is to write down the hydrolysis equation. So since NH4 plus is a conjugate acid, therefore water is going to be the base. This acid, the function of the acid is to donate H plus. Therefore, the donating H plus is going to form NH3 aqueous. Meanwhile, the function of the base is to accept H plus, forming H2O plus. Don't forget the hydrolysis equation is a reversible reaction, so please use the double-headed. Right? Simple. So, okay, you must write down the correct hydrolysis equation for CaCl2. So CaCl2 come from CaOH2, which is a strong base, and also come from a strong acid, HCl. So now write down the dissociation equation. CaCl2 dissociate completely into Ca2 plus aqueous and also 2Cl minus aqueous. As Ca2 plus comes from a strong base, so it is a weak conjugate acid. Meanwhile, Cl minus comes from a strong acid, therefore it is a weak conjugate base. Therefore, neither Ca2 plus or Cl minus will ionize the water molecule. Water undergoes auto-ionization. You can write down the auto-ionization equation of water if you want here. Dissociate partially into its cation and anion. Right, so if for the neutralization reaction between for the salt that is formed from neutralization reaction between a strong acid and strong base, there are no hydrolysis equation, but then we can replace it with a auto-ionization equation of the. Next, the last question. Still on NDH equation, we have a KCN salt. KCN salt come from KOH, which is a strong base, and also HCN, which is a weak acid. Next, we move on to the dissociation equation. KCN aqueous dissociate completely into K plus aqueous and also Cn minus aqueous. Since K plus come from a strong base, so this is a weak conjugate acid. Meanwhile, Cn minus come from a weak acid, so this is a strong conjugate base. So which ion are you going to choose for hydrolysis of water? Of course, the strong one. So Cn minus will ionize in water. So since Cn minus function as the base, so it's going to accept proton forming HCN. Meanwhile, this water is going to be the acid losing its proton forming OH minus. Simple, right? So before you leave the class, please scan the QR code below for your exit ticket. I'm going to check on you who didn't submit your work. Thank you for watching. Bye.